So starting with what does data engineering do? So data engineering as kind of like the core components or the core layer of a digital transformation in the, at least in the what I see for the next 5 to 10 years, data engineering will play one of the most important role for any digital transformations in any organization, because data is kind of the core, as the new most important assets for organizations to basically that can't be dived into any business lines any company is operating with. So for example, if they want to understand whether their marketing campaign does the job by say what's the conversion rate of the investment that they're putting into a different channels like Facebook or Google and so on and so forth. So they want to know how well their money spent with in terms of how many users that be converted, right? So that's kind of a quick example just showing you that data engineering as one of the most important think about a position in an organization will bring a lot of values, and it's one of the core team within the digital components, a digital department. So looking at the left, you can see that it basically gave you a general idea of what kind of data source or what kind of data you're going to dealing with. So including customer data, including email data and web pages, which those are highly unstructured, and it's going to be raw in nature, and you have to think about how to store and interacting with those data. Looking at video speech data is all in binary. You have to think about what is the best way and to saving those data, and how you are able to apply your analytics on top of those data to come up with some insights. Let's say if you are trying to find some anomalies, detections within the conversation between a call center with your customers, and see whether there is anything you can improve on, or any inefficient customer representative not doing not serving the customer well. Those are generally speaking the data you will be dealing with, but of course you will apply kind of data transformations as well as machine learning algorithm on top of those data, right? So sensor data is one of the very, very popular, but this requires some real-time kind of streaming capabilities within your organization in order for you to get data in a timely manner, and also able to react on the data quickly to get basically to quickly delivering the business expectations, like like fraud detection is one thing, and the other will be giving your customers some quick feedbacks. Those were going to be a very important process to follow with. So on the bottom, as you can see, that there are couple ways that you can setting up your data storage, or think about how you can serving your data. That's going to be including something called a lakehouse, as well as a data warehouse, which is traditionally we talk about you using some SQL database in general, or data warehouse in general, that able to take a SQL query and able to do some massive transformations and returning back the results. So we see Snowflakes as well as the GCP's BigQuery are those kind, and also in AWS we see there are services like Redshift is kind of doing those kind of warehouse components. But this is one way you can serving your data in your organization. And the other way is to using Lakehouse, which is if you are dealing with data that is super raw in nature, and you have to process it, and and also saving the data in a partition that is going to be scalable and also fault tolerance, then you will think about how to using the current Lakehouse setup, and S3 and EMR and Athena, which is using Presto, are the core components to stack them or put them together in architecture in order to serving the data needs within an organization, right? So moving to the right, you see that there's a streaming application. And there are things like Kafka, there's Kinesis, there's PubSub, which are the general tools and services which is helping us to quickly moving the data through the application and will give a timely feedback and also giving you a, like basically insights within a milliseconds, in terms of what's going on within your data, right? So this will be a important components for delivering quick insights. So moving to the bottom, you can see that there's NoSQL database. NoSQL database itself are it's really depends on the business model. So give you an example that Netflix is using Cassandra to serving their streaming data. If you are trying to watch some videos or watch some like films or something like that, then you will kind of reading the data from a Cassandra's database, or you can think about that as a NoSQL database, and you're streaming really from that particular partition or particular think about column family to getting the data back. So this really depends on the use cases, and the reason that Cassandra serve these use cases very well is because of the way how data is being saved up and also partitioned within the storage itself. So this is, kind of generally speaking, what are the storage will be available for us to, storing the data at rest. And this is not covering like how to save the data or push the data into the destination, like, the lake house, warehouse, and NoSQL streams. And also we're not talking about the serving layer. And those we'll cover those in the later of the slides. But think about this is just data at rest. Now, if you're moving to the right, you can see that those are, just if you're trying to break it down and think about what you're going to do on a daily basis, and this will be including design and develop and construct, install, test, maintain the complete data management and processing systems. And this we'll talk about different components that really work together to to have a kind of robust data ecosystem. We're not really talking about just the serving layer. Imagine that if you are working for an organization and they are pushing towards to a highly efficient and highly trustworthy data in their organization. Doesn't really matter using lakehouse or using warehouse, but the data has to be in a trustworthy state. So inevitable, you have to think about how to come up with a components, and that components have to serve the purpose of validating the data quality or the certain data rules in order to making sure that when the users interacting with the data, they have trust within the backends, right? So you have to come up with a components like, for example, there are popular tools like Atacama, which is it's a paid tool. It's a paid software that you have installed within your organization, within your cluster. And also there's open source like there's several open source tools, and the one of the most popular one is called Great Expectation, which is serving the purpose of you just need to write your data quality kind of definition, and the backends will be applying those kind of expectations or data quality rules on your data and giving you results. So this quick example, just to giving you like what kind of challenges or what kind of components as a data engineer you have to touch with, right? So as you can see, that it's actually quite broad, and also like you have to be responsible for think about how to installing those kind of components and software, and also how you're able to integrate with your existing components from scheduling piece perspective, from integration perspective. Those has to be, as a data engineer, it's going to be your responsibility to think about all those details. Building highly scalable, robust, and fault-tolerant system. So this is more as a non-functional requirement. So when you are, as a data engineer, dealing with the business or dealing with project manager, they're not able to giving you those kind of non-functional requirements. So but they can give you something like very general to say, it has to be 24/7 up, or like the availability of the data has to be 99.99. So it's going to be up to you to how you can using the existing services to decide whether you are able to delivering those kind of requirements or non-functional requirements. And that will be a combinations of leveraging the vendors, tools, and products in the cloud. Let's say in AWS, if we're using S3 to storing the data, we talk about 11.9, which means it's going to be highly available for the data storing in S3. And if you're using the accessing layer like Athena, which is backed up by Presto, then you will be having availability of, because it's a managed services, so you don't really need to worry about the availability. It's kind of, the resource will be available to you on the fly, all right? Mastering the end-to-end ETL process. Now, this is what I think is the core skill sets as a data engineer, is you have to making sure when the data is being introduced to your organization, you have to design an end-to-end solution. That's going to be including starting the the point where the data will be landing into organization, and that can be either the vendor drop the data to your, let's say for example, landing zone, or it can be just giving you a credential. And credential can be anywhere to, for example, a MongoDB. And you have to design a solution or process to how to efficiently get the data out of the starting points and travel through your data system, doing the necessary and mandatory steps like transformations, the data validations, the data governance piece, and then eventually saving the data back to your storage endpoints like S3 or HDFS or a data warehouse. So that data can be ready at rest, and next step will be serving the data to your customer, right? But you as a data engineer, you have to making sure from the starting points or starting journey of the data all the way to users SQL query, hitting the backend data, you have to making sure you are able to come up with a proper ETL process to accommodating these requirements. Next is design an architecture to satisfy business requirements and recommend the right technology frameworks to stakeholders. So this is a little bit advanced requirements for a data engineer. It's usually we talk about senior to principal level, that you are in charge of investigating on what is the right technology to use, what is the right vendor products that we should use. And of course, this is going to involve a broad domain of skill sets, including evaluating, the cost components, and also the pros and cons for using different technology. And also you have to, think about if you are using particular, say for example, languages or a framework, are you able to hire enough talents from the industry to process or to lift up the job, right? So those are the things that you have to participating with, your manager or your leadership teams to, come up with a proper recommendations of what to use. Last is research and developments on the new trends and technologies and quickly improve the values and plug into the existing systems and make the workflow more efficient. Now, this is more as a, advanced technologist, you have to making sure you stay ahead of the time, ahead of the curve, and understanding what are the new trend, what are the new technologies the industry is using. To give you a couple examples that recently people talk about Airbyte is very popular too, which is doing a very nice job with UI that able to do efficiently moving the data from point A to point B, which essentially able to take up part of this end-to-end ETL process. So before, how people is doing it is by writing some dummy code snippets, say moving data from a SFTP server all the way to S3 buckets, then you have to writing some code, or people using some tools like NiFi to accommodating those kind of process, right? But Airbyte does it to the next level, which means you're able really to stacking up your source and destination, and able to quickly getting those job and process done within, say 3 to 5 minutes if the infrastructure is up and running. So this is really speed up the job process and speed up the think about the data onboarding process. And also, it's going to dramatically simplify the amount of code, amount of components, amount of process that has to be managed by yourself or by your team. But instead, you can just leveraging a existing tool like Airbyte to really doing those kind of processing for you, in a non-headache way, right? So those are the things that you have to spending time to investigating with and making sure you are actually ahead of the curve. So moving to the next slide, and this is kind of one of the brainstorming, kind of think about is a whiteboard session, in a Saturday, in a Friday afternoon, and you just think about how you can optimizing the overall data processing flow in order to get the data more efficient within your organization. So you see from the left, you have a bunch of RDS, which is a relational database. Like, SQL database can be Postgres, can be MySQL, can be Oracle, those kind of SQL database, which is very, very common for a lot of use cases because if you think about it, like most of the company, if they are having some business operation that can be including if they are selling products and services online, or they have an inventory of their products in their warehouse, then they will essentially saving all those kind of informations in a relational database, right? They need the features of ACID in order to keep data in a good shape, right? So they need all those kind of features. And a relational database is able to providing all those features. Hence, this is still right now the most commonly used like database technology within any organization, right? So, but imagine that if those are going to be the production serving layer, which means if you're trying to make a purchase in Amazon to buying a book, and that's going to be being stored at a transaction table. And if you are as an analyst or as a data scientist to predict, for example, what are the how you're able to improve your inventory stocking process in order to say avoiding of any sold out products. Let's say if you are going to having a book online, for the, let's say, next couple of days, and when you are have it preparing for the to release and everything, and then you need to kind of making analytics to understanding for similar books and products, what is usually the the sale periods and sale process, and to predict that how fast or how soon you need to order the new book again, right? So if you're trying to apply such use cases within your live production database, then you will having a imagine that you are really competing with the resource with your production database, which it's going to be a really bad practice for your organization to follow, because if your customer who is actually paying for the products and they're waiting for the resource for analytics, then they will be not happy about the latency that introduced with this process, right? Hence, having a like offline process that able to load in the data out of the transactional database in a non-busy periods, and saving to a static object storage or a distributed file systems will be the better way to go for your offline analytics, right? So imagine that we have a offline process which is able to moving data out of RDS into S3, and then we are using kind of S3 to kind of as the starting points to save the data in the as a constant storage layer. So once data touch into S3, what we need to do next is we need to starting the a process, which is to transforming the data from S3 and move into your data warehouse solution like Redshift or maybe another RDS to use as a data warehouse layer. But this is going to including the validating, cleaning, and transform to moving the data from S3 into those data warehouse solution, data warehouse layer. Now, next is another layer that need to be introduced is to having a data management, or imagine that if you're having a specific view or specific data business requirements on the data formats, as well as the the granularity of the data that the business will be interacting with, then you have to think about what is the best way to moving the data and transforming the data and aggregating the data into the corresponding tables and database, right? So this is what we call data management layer. Now, once the data moving into those layers, then you will applying the OLAPs and imagine that if you are going to having a BI tool like a Tableau or Superset, those kind of BI tools interacting with your data, then you have to come up with a like a layer or a connection to interacting with those data warehouse interface, right? But of course, there are better ways, or there's another approach, or a more cost effective solutions, which is rather than directly interacting with Redshift RDS, and those are the components and infrastructure that you have to maintain yourself. You can optionally, using some serverless, which means you just need to pay what you use, but you do not need to caring about or paying for the part that you are not, using with, right? And we'll talk about that in a bit. But this is one of the use cases which is, doing reporting purpose, and the other is using data scientists, tools and process to really getting more insights with the data that you're having within your data warehouse. This is a typical batch process, which means there is some latency being introduced, is depending on how often you are moving the data from the RDS to S3. But there is also a hybrid mode, which is in real time. We call this CDC. It stands for change data capture, to moving the data in real time out of the RDS database and into a destination like S3, so that you can query the data in an offline application storage like Lakehouse to avoid of competing with the resource within within RDS. Moving to the next page, which is this is a kind of a more pretty modern and also a pretty standard architecture or process for data engineering to follow. Imagine that you have all kinds of data coming from different sources and different vendors, and those data, some of the data will come in as real time, and some of the data will come in as static, files. And let's say, for example, if you have any legals and transaction files, then this will come in through a static file channel. But the rest, like IoT data or Twitter data, which you want to get in those in real time, then you want to use in the messaging queue. So now, if you're looking at this, then what's actually happening is on the bottom is when data coming into the real-time messaging queue, and this real-time messaging queue will be leverage and also will be reading out of from components like Spark Streaming or Flink. And those are the general technology which is able to moving data out of a messaging queue in real time and able to do operations like inserting or upserting the data into a downstream process, and so that you're able to query the data with tools like Presto. So do not worry about if some of those terms and technologies doesn't make much sense, but you can just try to imagine that as a as a user, like when you're trying to interacting with the data, what kind of requirements you were having ahead of time, right? Like, are you trying to, let's say, see the data with a latency of, let's say, a couple of minutes, or let's see a latency of a couple of seconds, or you're tolerated with a latency of 1 day or 2 days, right? So those going to be depending on those requirements will drive different architecture and different technology decisions on delivering different use cases. But if you're moving to the top, which is the static file process, then you are really trying to move in the data through the ETL process, which is moving to the data warehouse and segregated into different different staging zone, like the marketing, the risk, and the compliance and transactions, so on and so forth. And then you will kind of using the BI tool, as I mentioned earlier, to directly reading the data which is coming in batch, as well as data coming in as a streaming application, but you are able to mastering all the data together in a single BI tool, but enabled by different connection source, right? This is one from static, the other is from real time, right? So from machine learning perspective, most of the time, or 99% of the time, you are leveraging the data which is static, because you want to control the variance of what is the data you are processing with, right? So if you are taking the data which is coming in real time, and then if you're trying to apply your models with the data, a couple times, and the base data are changing over time, then you will suffering from, not able to identify what exactly the variable has been changing over time, which yield the unstable, let's say, performance of the algorithm you're working with, right? So this is the kind of the combined the real time as well as the static file approach, or the batch approach.